Positive expected returns do not guarantee survival. A process with positive drift can still be absorbed with probability 1. The expectation averages over all futures, including those where the process is already absorbed. Survival requires the process to stay above the barrier at all times. This is a path condition, not a distributional one. Optimizing for expectation does not optimize for survival. Consider a process with positive drift and an absorbing barrier at 0. The expected value grows, but individual paths can still be absorbed permanently at 0. Once absorbed, a path contributes 0 to the expectation at all future times. The growing expectation is carried entirely by surviving paths. The expectation can grow while most paths decline. For geometric Brownian motion, the expected value grows at rate mu. But the time average growth rate of a typical path is mu minus 1/2 sigma squared. When this quantity is negative, most paths drift toward 0 and are eventually absorbed. The expectation grows because rare surviving paths take very large values. Ruin is certain when the time average growth rate is negative. The expected value and the median path diverge over time. The expected value grows while the median path declines. This reflects the asymmetry of the distribution. A small fraction of very large outcomes pull the mean upward while most paths go nowhere. The expectation is dominated by the right tail. Decision-making based on expectation alone ignores what happens to the typical path. For jump processes with heavy right tails, rare large jumps sustain a positive expected value. Between jumps, the process drifts downward. Most paths never receive the large jump and drift steadily toward the barrier. The expected value is sustained by the few paths that jump at a favorable time. Heavy right tails decouple the mean from the survival probability. Consider a game where you win 3 times your bet with probability 1/4 and lose it with probability 3/4. The expected return per round is 0, yet the probability of eventual ruin is 1 with repeated play. Ruin follows from the absorbing barrier, not from the sign of the expected value. Expected return is the wrong criterion for games with an absorbing barrier. Survival requires the time average growth rate to be positive. For geometric Brownian motion, this means drift minus 1/2 variance must be positive. Positive drift alone is not sufficient. The full condition depends on drift, volatility, jump structure, and initial distance from the barrier. Positive expected value is neither necessary nor sufficient for survival.